All right, now we're going to look at a method of solving quadratics called completing the square, which is another method. And I know what you're thinking. This is awesome. I can't wait to have another method of solving quadratics. Let's review what you have in your toolbox so far. You can solve quadratics via factoring, set things equal to 0, factor, set your factors equal to 0 and solve. You can solve using square roots, so that's isolating the variable and then taking the square root of both sides. Let's see how this works now. I have a problem, x squared minus 8x plus 16 equals 25. And if we were to solve this via factoring, you say, okay, well, using square roots, subtract 16 from both sides, you get x squared minus 8x equals 9. And there's no real convenient way to deal with this linear term. When you solve via square root, I don't know if you've noticed, but there's been no linear terms, just quadratic terms and constants. So, I guess this isn't going to work out. Let's try by factoring. If we're going to try by factoring, then we're going to set this equal to 0, so we're going to subtract 25 from both sides, and we're going to end up with x squared minus 8x minus 9 equals 0. Set up our sets of parentheses, and you get x minus 9, x plus 1. That'll give us a negative 9 on the multipliers, the last two, and that's definitely going to give us a linear combination of a negative 8x, so we're going to get a final answer of 9 and negative 1. All well and good, but let's see if we could try another method and arrive at the same conclusion. So let's just make a note, 9 and negative 1. Our new method is going to be looking at completing the square. Well, first, let's take a look at this. This one doesn't really need to be completed. This is a perfect square trinomial in the fact that this is x minus 4, or better known as x minus 4 all squared. I think you get the point of why we've been doing so much factoring practice for Quizlets. Now, we got x minus 4 all squared equals 25. This is what some of your solving using square roots look like. So you say, oh, I take the square root of both sides, because I can take the square root of that, and that's going to be x minus 4 equals plus or minus 5. So x is going to be equal to 4 plus or minus 5, and 4 plus 5 is equal to 9, and 4 minus 5 is equal to negative 1. So x is equal to 9 and negative 1. Nice. Okay, well, let's try a couple more examples, one that works out really nice and one that doesn't work out so nice. On the left side, let's see if we can factor this up. That's x plus 3 all squared, right? X plus 3 times x plus 3 equals 36. Take the square root, both sides, and we're left with x plus 3 equals plus or minus 6. Subtract the 3, and we're left with x equals negative 3 plus or minus 6. And we can get two solid answers. Negative 3 minus 6 is negative 9, and negative 3 plus 6 is 3. So that's going to be our two final answers. And again, taking into consideration on this original piece that this parabola opens up if you subtract 36 from both sides. It doesn't matter. We're going to have a negative y-intercept, but I know that this opens up. And I know that negative 9 and positive 3 are where the parabola crosses over the x-axis. That's the big idea. That's why we keep looking at the pictures as well, keeping this all together, sort of all the balls in the air at one time. Okay, so I got x squared plus 10x plus 25. So that's x plus 5, or x plus 5 squared equals 3. Square root of both sides of that, and we get x plus 5 equals plus or minus the square root of 3. Subtract 5, and this is going to be x equals negative 5 plus or minus the square root of 3. Now, no one said all of the answers are going to work out really nice. So that is what it is. That is a real answer. It's just not a rational answer. But we could approximate it. 5 plus and minus the square root of 3. Well, the square root of 3 is around 1.73. So that would be 6.73, and negative 1.73. Those would be our two approximations for that answer. But this is the preferable answer. I'm just saying when we look at this as far as a graph is concerned, if if this is 2 and this is 1, and this was, 6 and 7, then our spots are here, and the parabola goes like that, just for ha-has. Well, the question remains is what happens when it's not a perfect square trinomial? Like take this value of c. What would the value of c be to make this all work out to be really nice? Well, take half of 14. Half of 14 is equal to 7, and 7 squared is 49. So if you had x squared plus 14x plus 49, that would be x plus 7 all squared. You see, half of this value is going to be that number right there every time. Let's try another one. What's the value of c that makes this work out to be a perfect trinomial? Well, half of 8 is 4. 4 squared is 16. So x squared plus 8x plus 16 is a perfect square trinomial, x plus 4 all squared. If you square this out, x plus 4 times x plus 4, you'll end up with that. Those are the two similar expressions of the same value. All right, now let's put this into play. Now this problem is not solvable via factoring or by square roots, so we are forced with coming up with another alternative. Now, half of 12 is 6, and 6 squared is 36, and this ain't 36. So what we're going to do is we're going to subtract 4, and we're going to get x squared plus 12x plus, and we're just going to leave a space, equals negative 4 plus something. Remember, in algebra, if we do something to one side, we've got to do the other. Half of 12, off on the side, half of 12 is 6, and 6 squared is 36. So if I made this 36, that would make this nice x plus 6 all squared. Beautiful. But I added 36 to one side, so I got to add it to the other to keep my equation in balance. 36 minus 4 is 32. Now I continue to solve, take the square root, x plus 6 equals, and I take the square root of 32, which would be 16 times 2, or plus or minus 4 radical 2. Subtract the 6, and I'm going to get x is equal to negative 6 plus or minus 4 radical 2. What? That was a tough one. Let's try a couple more. All right, we got x plus 6x plus 4 equals 0. Not factorable, and 4 isn't the value that makes this a nice perfect square trinomial. So I'm going to subtract the 4, get that out of the way. X squared plus 6x plus, I'm going to leave a little space, equals negative 4 plus, and I'm going to leave that space. I'd recommend writing it just like this so you don't forget to put values in here and here. This is the big one that everybody forgets, the right side. Half of 6, right? Come over on the side. Half of 6, 3. 3 squared, 9. That's the magic number. Now, how do we express this as a perfect square binomial? It's that half value, x plus 3, all squared, equals 5. Okay, take the square root, x plus 3 equals plus or minus, don't forget 2 answers, square root of 5, can't be simplified. Subtract 3, Notice how I leave that space here so I can put the 3 there. It's all about form. Watch my form, very consistent. Negative 3 plus or minus radical 5. Now let's remember that, negative 3 plus radical 5 and negative 3 minus radical 5. Those are the two x intercepts, or your zeros, or the roots, depending on how you look at this. All right, there's two things going on here. Let's try a couple more versions. Now, what happens here is we have this coefficient of the quadratic term is not a 1, it's a 2. So what could I do? It just so happens that everybody here is divisible by 2. So I'm going to divide the whole left side by 2 and the whole right side by 2, leaving me with x squared plus 4x plus 7 equals 0. Now, the world is good. Subtract 7 from both sides. I'm going to get x squared plus 4x plus what? Yes, space equals negative 7 plus the space. Half of 4 2, 2 squared, 4. Okay, so coincidentally, 4 is that funny number that's when you double it or square it, it's the same thing. Okay, so now we go to factor this. What do we got? We got x plus 2, right? Half of the linear term, all squared, equals negative 3. Take the square root of both sides, and I'm going to be left with x plus 2 equals plus or minus square root of negative 3. Now I'm going to do two things at one time. Subtract the 2 from both sides, and I'm going to have x equals negative 2 plus or minus, and don't forget that's a negative 3. So we're going to say, hey, pull out my imaginary unit. Negative 2 plus or minus I radical 3, and that's our final answer. Go ahead and box that baby up. Now I know what you're thinking. You're dying for a geometric word problem. Well, here's a haphazard version. We've got a rectangle with a given area of 72 square feet, dimensions of x plus 2 and 3x. So what do? We react. We say, hey, 3x times x plus 2 is equal to 72. Now, how should we solve this? Well, how about we go ahead and we distribute this, see what we get. We get 3x squared plus 6x equals 72. And just taking a quick look at this, you say, you know what? Everybody on the left side is divisible by 3, and 7 plus 2 is 9, so that's divisible by 3, so is 72. Okay, so that's going to leave us with x squared plus 2x equals 24. Keep your world simple. Always look for reducing when possible. You know, it's my favorite move. So now let's see here. X squared plus 2x plus what value equals 24 plus what value? All right, half of 2 is 1, 1 squared is 1, so we're going to add 1 to both sides. All right. See, this thing wasn't solvable by factoring, was it? Perhaps it was, but, you know, this is just as fun. X plus 1 all squared equals 24 plus 1 is 25. That's a shiesty 25, so let's fix that. That's a great fix, huh? Take the square root, x plus 1 equals plus or minus 5. Now, when this is a perfect square on the right side, this plus or minus 5, that's how you know this was also solvable via factoring. But you don't know it until that point. Okay, so that's x equals negative 1 plus or minus 5. So negative 1 plus 5 is 4, and negative 1 minus 5 is negative 6. Okay, and those are our zeros. And up here, just for the record, if you had said that this was x squared plus 2x minus 24 equals 0, you would have said that that was x minus 6, or plus 6, x minus 4 equals 0, and then you would have got what? Minus 6 and positive 4. So, again, we have options. Your mission, should you choose to accept it, and you should, 1, 2, and 3 for homework. See you at the class. This should be done.